Multiply or divide by a positive number. So here we have an inequality. 3x is greater than negative 36. And if we're asked to solve for the variable, we need to get the variable x by itself. So right now it's being multiplied by 3. So we would want to divide both sides by 3 for that inverse operation. That's going to undo multiplying by 3 and leave us with our solution. X is greater than, well, negative 36 divided by 3 is negative 12. Very similar to if it were an equation, the same thinking. Here's another example now with a fraction, but we have 2/3 times r is less than 4, so we're going to solve that inequality. We need to get the r by itself, so we need to, since it's being multiplied by 2/3, we need to divide by 2/3, but we don't divide by fractions. We multiply by the reciprocal, which is then 3/2. That is undoing multiplying by 2/3. And then we have 4 times 3/2, so r is going to be less than 6. You could also multiply by 3 and divide by 2 if you wanted to take 2/3 as 2r divided by 3. Both will give you that same answer of 6 though. When you multiply or divide by a positive number, the inequalities are again following those same rules as when you solve equations. Multiply or divide by a negative number. Now let's see what happens when we multiply or divide by negative numbers when solving inequalities. So sometimes we have to multiply or divide in an inequality to isolate the variable. But multiplying or dividing both sides of an inequality by a negative number gives us a surprising result. Now, instead of just telling you the result, there's a lab that's designed to have you discover what happens when we divide or multiply by a negative number. So the lab comprises 2 parts that you should definitely investigate and explore, and I'll give you one example of part 1 and 2. So part 1 and 2 of the lab has you coming up with 2 different numbers and putting the appropriate inequality symbol between them. I really encourage you try to create your own 2 numbers. Mine is just a very random example. I'm going to choose 4 and 8, and the appropriate inequality symbol between them, I have to know that 4 is less than 8. That is my example. I encourage you to choose a different one and follow along to see if you're going to get the same surprising results. So now with 4 is less than 8, I'm going to apply each rule for A through F to these original 2 numbers and then try to put the correct inequality symbol between their answers. So first I'm going to add 4 to both 4 and 8. So that will give me 8 and 12. Which is still 8 is less than 12. Then I'll subtract 4, so 0 and 4, and still less than. 0 is less than 4. I'll multiply by 4, so 16 and 32, still less than. I'll multiply by negative 5, so negative 20 and negative 40. But now the symbol to make this a true statement would be greater than. Okay. Then I'll divide by 4. So 1 and 2. So now 1 is less than 2. So now back to less than again. And I'll divide by negative 4, which will give me negative 1 and negative 2. But to make this true now is greater than. So it seems that this is the rule. And these are now the new signs that has to go between with the effect of this operation. So the second part of the lab asks you a bunch of different questions. It asks you to compare results with someone else and then to generally write a rule for what is happening, to compare the results, to see patterns, to look at the symbols. If we look at our numbers, if we look at our inequalities, you should try and see what you notice. And hopefully you see that in D and F, The one major change is the inequality sign flipped. Instead of less than, like the original sign, now it's greater than. And in D and E, the difference is that you're multiplying and dividing by a negative number. So if we're asked to write a rule for inequalities, we can say that the direction of the inequality changes only if the number you are using to multiply or divide by is a negative. So again, the direction of the inequality changes only if the number you are using to multiply or divide by is negative. So let's now see this rule in action. Here's an example of when we would use it. Our directions are to solve and graph, and we have negative 3y is greater than or equal to 18. So to isolate the variable, right now it's multiplying by negative 3. So we would take that and we would divide both sides by negative 3. But because we're dividing by a negative, the sign changes from greater than or equal to less than or equal to. And then that undoes multiplying by negative 3, and 18 divided by negative 3 is negative 6. So we have our solution set of y is less than or equal to negative 6, which is a closed circle at negative 6 with a ray to the left. Here's another example. We have negative 7m is greater than negative 28. So we have multiplying by negative 7m. So we're going to divide both sides by negative 7m, which undoes the multiplication. But because we divided by a negative number, we have to switch the sign to give us m is greater than 4. So that'll be an open circle at 4 with our ray drawn to the left. Here's another example. 5m is greater than or equal to negative 25. So here we're multiplying by 5. To isolate the variable, we'll do the opposite, the inverse, and divide both sides by 5 to undo that, which will give us m is greater than or equal to negative 5. Notice, the rule did not apply here. I divided by a positive 5. It doesn't matter that the quotient was negative. It's just that the divisor wasn't negative. So our sign stays the same. So we'll have a closed circle at negative 5. And we will have our shading to the right. Here are two more examples to practice that rule and when we should use it or not. So we have negative 8y is greater than or equal to 32. So multiplying by negative 8, I'll divide both sides by negative 8 to use the inverse. Now I'm dividing by a negative number, so I have to switch the sign from greater than or equal to less than or equal to. 32 divided by negative 8 is negative 4. So I'll have a closed circle at negative 4, and my shading will be to the left. I have all numbers less than negative 4. I have number 2, negative 9f is greater than negative 54. So I need to undo multiplying by negative 9. So I'm going to divide both sides by negative 9. Again, dividing by a negative. So it'll isolate my variable, but greater than will become less than. And negative 54 divided by negative 9 is 6. So that will be an open circle at 6. And then I'll have my shading to the left. All numbers less than 6. Here, I have negative r is less than 2. So I have less than or equal to 5. So here, right now, you think we're going to multiply by 2 so that the inequality sign wouldn't change. But you're really going to multiply by a negative 2. You're going to take into account that there's that negative in the numerator because we want to undo the 2 and the negative at the same time, which would then leave us with r is greater than or equal to negative 10. Right? You multiplied by a negative. We have to apply the rule. So here we cannot leave this as greater than. we multiplied by a negative number, even though at first it didn't look like it. So we can't leave it as greater than or equal to. We have to have r is less than or equal to. Oh, no, wait. No, wait. Okay, so let's start from the beginning. Just to review, the original sign was less than or equal to, and they switched it already in this first step to greater than or equal to during the multiplication. So then it is greater than or equal to. It started out as less than or equal to. It is now greater than or equal to. All because, again, we did multiply by a negative. But all in all, that does mean we have a closed circle at negative 10 with our shading now to the right. And that's really where the rule comes into play, is because your shading, if you didn't switch your sign, your solution set would be wrong. The shading would be in the opposite side. So you have to take into account where you're starting. This was a little bit of a trickier example because we had that negative on the top. You could have also thought of this as a negative 1/2. R is less than or equal to 5, and you could have multiplied both sides by the reciprocal, negative 2/1, but that would have still achieved the same result since you're multiplying by a negative number still, so you'd still have r is greater than or equal to negative 10. Let's get more practice still. We have negative 6h is less than 42. So we'll divide both sides by negative 6 to undo multiplying by negative 6. And we divided by a negative number, so we will switch the sign to be greater than. So we'll have 42 divided by negative 6 is negative 7. So h is greater than negative 7 will be an open circle at negative 7 with our shading to the right. And if we have 4x is greater than negative 20, we'll divide both sides by 4 to undo multiplying by 4. Now we divided by a positive, so my sign actually will stay the same. We can't go crazy and just start switching the sign all the time when we're solving inequalities. It's only, again, when we multiply or divide by a negative. So this will be x is greater than negative 5, an open circle at negative 5 with our shading to the right. Here are two more examples. 5m is less than 30, so we'll divide both sides by 5 to undo multiplying by 5. So m is less than 6, an open circle at 6 with our shading less than, all the numbers less than to the left of 6. And we have a divided by negative 2 is greater than or equal to negative 3. So we'll multiply both sides by negative 2 to undo the dividing by negative 2. And because we're multiplying by a negative number, my sign will switch to less than or equal to 6. So that's a closed circle at 6 with my shading to the left. My shading less than that negative, less than that 6. So again, we have to keep the rule in mind, but just be on the lookout for it, not do it all the time. It's only, again, when you multiply or divide by a negative number, we switch the sign. That's the major difference with solving inequalities and equations, as well as the graphs of their solutions aren't just one answer. It's a section, it's an array.